There we go. All systems are go with the click of a button. All right, awesome. So welcome everyone, and welcome to this Discord training that we're doing here with identifying IP hosts. I'm Dave Prouse, and welcome to everyone who's joining in today or listening to the recording. And so this is the first Discord training that I have done, the first Discord live session. So we'll see how it works out. It's a bit of give back for the holiday season. And I don't know what exactly I'm going to do with this. I'm not sure if I'm going to do live training on Discord or on YouTube, and whether I'm going to do specific topics or maybe do a monthly Ask Dave session, that type of thing, and keep it open-ended. We'll have to see. So this channel has a built-in chat, and if you hover on the actual title of this channel, Linux Training, you'll see an icon for a little chat box, a little comment box. And you can also get to that if you're in the channel by hovering in the upper right-hand side of your of the window. You'll see the chat icon. Okay, so if you have any questions, that's where you ask them in the built-in chat within this Discord channel. Okay, so at this point, what I'm going to do is I'm going to share off my screen and we'll get started. So I'm going to share that now, and give me a moment here. To complete this. All right, full screen projector, go live. All right, there we go. Good. So the stream is running. Let me just check if it's running properly. Okay, and it looks like it is. Okay, good. All right, so you should be able to see me on my webcam as a person, and then you should also be able to see my screen share, and I'm there as well. I'll be kind of jumping around the screen like this, right? So you can watch along with that. Feel free to double click on the web stream, and you can make that a larger size. Okay, so that's it. So let's get into it. Here is what we have on the agenda today. We're going to be doing a lab. We're going to be working with NMAP, and we'll spend the bulk of the time working with that. Then we'll get into some other commands like IP neighbor. We'll show the Angry IP scanner program. We'll show how to use FPing and a little ARP, and briefly talk about for and while loops. We can use all of these tools and programs to identify IP hosts on your network. All right, excellent. So let's go ahead and get into it now. We're going to start with the NMAP program. And so I have a virtual machine running, so I'm going to be working in that, and also my main testing system over here. And so here is one of my virtual machines. This is a Debian client, so I'm going to log into that now. Okay, good. So any Linux system will do. It's really fine, whatever you want to use. We'll close out of this. This is a Debian client, and I'm just going to open a basic terminal here. So open a basic terminal, and if we run the nmap command, that's the first program I want to work with here, you'll see that the command is not found, and that's because it's not installed. Okay, so we need to install it. And there's a variety of ways to do this. If you're in Linux, the easiest way is to do it with the package manager. But if we look over here, you'll see the download page. And I'll copy that into the chat. And so you can download this here for Windows, Mac OS, Linux, or any other OS, right? So that is an awesome way to get it, but it's a lot easier to get it by way of package manager. So that's the easiest. So if we're on a Debian system, we'll do a sudo apt install nmap. and replace your package manager with whatever your Linux distro is. So if you're running Fedora, it's DNF. If you're running Arch or what have you, it's Pacman. If you're on Debian and or Ubuntu, it's going to be apt. So I'm going to do a sudo apt install nmap so we can install that program. Type in my password, and we'll say yes, and we'll grab that guy now. Okay, awesome. There it is, it's installed. So now if we do an nmap -- we should see the version for nmap. We're running 7.93. Now, if you're on macOS or Windows, you can grab it from that link that I put into the group chat. Or if you're on macOS, you can use ports. That's a port install nmap. Or my favorite is brew. So it would be a brew install nmap. Okay. If you're in Windows, I like to use Chocolatey. And if you have that, that will be a Choco install nmap. Awesome. All right. So lots of ways to install it. Just want to make sure that you get it on your system. So that is first. All right. So now let's do some work. Let's actually use the nmap program now that it's installed. I'm going to do some work from the virtual machine and some from my main system. So this virtual machine, if we run an IPA, we'll see the IP address of this system is 10.0.2.52. Okay. And so that means that I'm on the 10.0.2 network. How do I know? Because I have a /24. That's a 255 net mask. So I know that 10.0.2 is the network. And there's other systems on this network. There's the gateway device, and I have a Debian server here, another virtual machine, and this one's on 10.0.2.51. So we've got a couple different hosts here, and so we can scan this network with nmap to see what is available. Maybe there's more, maybe there's not. I don't know. But let's do that now. So we'll do an nmap-sn, and we'll take a look at our network, but I just want to see the host IPs. I don't want to see all the ports just yet. I want to see the host IPs here. So we'll do a 10.0.2.0/24 and search the network. That starts up. It's going to scan the entire network, which is just going to look from .1 through .254. And it finds 10.0.2.1, that's the gateway, 10.0.2.51, that's the server, and 10.0.2.52, and that is my system. That's the Debian client. It tells you 256 IP addresses scanned, 3 hosts up, and it only took 2.43 seconds to do that. Very good. Now, it actually does 0 through 255, but 0 is the network number, and 255 is the broadcast, so I'm not really concerned with that. What I'm more concerned with is 1 through 254. Excellent. So let's do another scan. Let's go to my other system here, and let's go into my super labs. I'm going to change over to this directory that I created here, and let's do a scan from here. So if I was to scan the network that this system is on, and by the way, the system's on a lot of networks, but if I was to scan this network here, 10.42, and I know it's 10.42 because of the /16 here, if I was to scan this IP network, it's going to go through a whole ton of IPs. It's going to go through 10.42.0.1 all the way through 10.42.255.254. That's a ton of IPs, 65,000 IPs. So that could take a long time. It could take 10, 20 minutes to get that done. So you can specify a range if you want to. Instead, you could do something like nmap-sn and then specify 10.42.0.1 through 100 or something like that, right? And we'll see how quick that scan is. So that just looks for 100 IP addresses, and it says 11 hosts up there. So that command was this, a little bit easier to scan just sections of a network if you want to do it that way. Okay. Another thing that you can do, and one of the other networks that I'm on here is this Soho network, 192.168.41. If we were to scan that, we could do it NMAP 192.168.41.0/24, and that'll look at everything on that network. I'm not too worried about doing the entire network at once because it's just going to do 256 IP addresses. But we could then push that out to a file. If I don't want to see the results in the standard out in the terminal, then I could push that to a file. I'll just call this nmap.txt. And you know what? Let's change over to my nmap directory first, and then we'll run that and write it to file. There, we're done. If we look inside here, we'll see there is an nmap.txt file. And if I look at that, we'll just go bigger on this terminal. We'll see all the information from that. Okay, so it found various systems, and it's showing the ports as well for those systems. Okay, good. All right, so a couple options for NMAP there. Let's go back. And go back to our virtual machine here. Okay, good. And so let's do a little bit more scanning. So in a virtual machine, we saw, and let me go full screen on this, we saw that we had 3 IP addresses found. Gateway address, a server, and this particular system, 10.0.2.52, the one that I'm sitting at, the one I'm working at locally. All right, so let's do a scan of the gateway and see what we see. Because normally, by default, if you do a -SN against an entire network, you're just going to get a scan report saying whether the host is there or not for each IP. Now, if you want to find out more about that host, you could do that simply with an nmap and the IP address of the host in question. So I'm going to do an nmap on 10.0.2.1 and press enter. That is the gateway device, and we can see that it has port 22 open, which is SSH. So it's allowing SSH connections. We see that it has port 53 for DNS, port 111 for RPC bind, and 2049 for NFS. And so that is the virtualization gateway. It also deals with DNS. It actually hands out IP addresses as well. Okay, so that is one example. Now let's take a look at the server. 10.0.2.52, the 10.0.2.51. So we'll change this. The only thing that's open on that Debian server is SSH. Good. So far, not really anything much in the way of security issues that I'm seeing. So that is okay, not a big deal. But this is how we're showing some basic scans to start. Let me go back to my main system here. And let's run a scan. I'm on this network. The gateway for this particular network is 10.42.0.1. So let's do a scan of that now. So we'll do an nmap on 10.42.0.1 and take a look at what is there. Okay, 3 ports open on this. We've got 53 for DNS and 80 and 443 for HTTP and HTTPS, respectively. So the question is going to be, do we really want 80 open? Can we just do 443? What we really need is a proper certificate on this system. This is actually my gateway. It's one of my gateways, and it runs FreeBSD with a firewall built in. So the question is, do I ever need to connect to that with port 80? No, normally I want to just connect with 443 HTTPS. We need to make sure that we have a proper TLS certificate on that guy. So that's some of the work I have to do on this system, right? Okay. Let's take a look at another system. Now we saw when we did this in this terminal here, and I'll make that full screen, we wrote that to a file. So let's take a look at that file again. And if we look here, we'll see several IPs. This is the 104 is one of my systems on the network. We have 102. We have 100. Okay, that's all closed. And we have .1, which is actually the Soho router for that. One that's not showing here is 103. So I'm going to do a scan of that directly. So that's going to be an NMAP 192.168.41.103. And quite often what's going to happen with this is it's not going to see the ports very quickly. So we can kind of, or it might not be able to get through to that host. Perhaps it has a firewall or something like that. So the -PN option will help us to do that. So we're going to run that and let that go for a minute. Okay, let that, oh, and actually it was pretty quick. So now we do see the ports for this particular guy. And so what do we have? We have port 22. That means SSH is running. We can SSH into the system. Port 135, MSRPC, remote procedure call. 139, NetBIOS session. Port 445, that is Microsoft DS or directory services. 3389, Microsoft WBT server, otherwise known as terminal services, and the real name today is remote desktop. And port 4000, which is remote anything. Okay, so what is this system? Well, we could also try doing something like this. We could do a -O to try to have NMAP guess at the operating system. Okay, we have to do this with sudo privileges here. So let me type in my password and give that a moment to try to guess what the system is. But it may or may not be able to see very well. If you're looking where I'm looking, you're seeing NetBIOS session here. You're seeing Microsoft directory services. You're seeing remote desktop service. You're seeing MSRPC. That all screams out that this is a Windows system, right? And so just guessing, hey, maybe it's Microsoft XP 7 or 2008. So some really outdated stuff here. Aggressive OS guesses, Microsoft Windows 7. So this is not what it is. It's a Windows 10 laptop. So this may or may not work so well for you, but you can see that you do get a lot of information here. Okay. You can also scan via port. So let's say I was to do something like an NMAP 10.42.0.1, and you just wanted to look at specific ports. Instead of doing a range on this system, which you can do, you could do specific ports. You know, by default, NMAP will scan the first 1,000 ports. In this case, it found 997 filtered, so it couldn't get through to those, but 3 that were open, so 1,000 altogether. So it only scans the first 1,000 ports by default. But you may want to do less than that. You may want to just scan for something like port 22. You could do that with the -P, and it'll just check that port. Okay, or you could do multiple ports. You could do T for TCP-based ports, or U for UDP-based ports. So, for example, we could do T:22, 80, 443, let's say 53, let's just do a rare one, 4,000. So we'll press enter for that. It's going to look for those ports, and it's going to tell you, yeah, 53 is open, 80 is open, 443 is open, but no, 22 is filtered, and 4,000 is filtered also. So sorry, we don't have information on those, right? So a lot of options here. You can scan a single port, a group of ports, or all the ports on the system by default. Okay, let's do a scan here on another system. This time we'll do another system on my network that's .15. Okay, immediately we get the response. And so firewalling isn't really working on this system. That's the first thing I can tell right off the bat. If firewalling was in play, NMAP would probably take longer, and or you'd have to force the probes to work properly with a capital P N, right? So a lot of options there. But when we do that command, we see that port 22 is open, okay? And that is SSH. We also see port 4000 is open, remote anything. That's actually no VNC, excuse me, that's actually name totally escaped me just now. It's a program I use all the time. It's NoMachine. I almost said no VNC. It's called NoMachine. I use that on my local area network. I don't really use that on the internet, and it allows me to connect out to just about any system in a graphical manner. We also see 8200 TrivNet 1 and 9090 Zeus admin. Okay. Well, 9090 is cockpit. It's system control through the web. So you can use a browser to try to control a remote Linux system. I don't necessarily want that on this system, but who knows? We'll take a look at the system in a minute and see what the deal is. 8200 is used by a lot of different services. It's used by services that allow the encryption and copying of information. It's used by lots of different web-based services. So TrivNet 1 is a little bit, it's a little confusing. We're not exactly sure what that is right now. So we should check it out. We should go to this system and find out what exactly is going on there. So I'm going to go to a second terminal here, make it a little bit bigger, clear it, and we'll do an SSH to sysadmin, which is the name of the account on that particular system at 10.42.0.15. Okay, I'll type in the password of that account on the remote system. And look what happens. It tells us, oh, you're welcome. You're in Ubuntu. So this is an Ubuntu 22.04 system. Okay. And they're telling you, hey, you can use the web console to connect on port 9090, right? That's that cockpit or web console to connect to it from a browser. We could try that. We could either click on that or we could connect via a browser. Let me open a browser here. And we'll try connecting to that now. Okay. Now, this obviously does not have a proper TLS certificate because we're getting the exclamation point. We're getting the HTTPS crossed out. It says not secure. But I'm just going to go to advanced and try to connect. And it is actually allowing me to connect in to the web-based console to take control of that system. So I don't think I want that. And so I'm going to shut it down. What it actually is something called cockpit.socket, and that is active and running. That's what allows the connectivity. It listens on port 9090 in IP version 4 and IP version 6. So that's enabled right now. That's pretty nutty. I mean, it's great for making connections and doing configurations. And in fact, let me just show it real quick. I'll connect this sysadmin because this is on the remote machine. Log in. There we go. And this person has administrative access by default. We can go to the logs, see what's going on here. Oh, Nouveau failed. Not surprised. The video's not really working properly over there. So we'll check that on that Linux system. But anyways, we can see everything here. The storage that we have here, all of the network devices, and you can see there's a bunch on this system. So we can make all these changes here. The problem that I have with this is that it's web-based. Right now, it's not even secure, right? It's not secure at all. It is not using a proper TLS certificate. That's a problem right off the bat. But even if it was, web-based sessions are typically not secure in general. A lot of bad things can happen with web-based systems. I would rather control this system in the command line via SSH, which is a much more secure way of doing so. And so what I want to do is I want to shut down Cockpit. All right. So we're seeing a reason to use NMAP here. We found out with NMAP that 9090 was open. That's always a red flag for me. Some companies use it. I don't really recommend it. It's fun. It's graphic, but I don't recommend it. So that's why we SSH'd into that particular system, so we could see exactly what it is and shut it down if necessary. And I'm going to do just that. I'm going to do a systemctl /now disable cockpit.socket. It's not .service, it's .socket for this particular system. Cockpit was always the name, but you know, it's also known as the web console. That's the actual name today. But as far as the service or the socket goes, it's called Cockpit. So I'm going to disable that altogether. I have to authenticate for that. Okay, I thought I authenticated correctly. Let's try that one more time. Okay, that asked for that 3 times. Let's see if it actually worked. And let's do a status on it, and there you go. It is inactive now, and it is disabled. Fantastic. So that's essentially what we needed to do. We needed to shut it down, and we did that with a /now disable. That stops the service, and it disables it permanently, so it's persistent. It will not start up when the system starts. Okay, so that is what we get here: inactive and disabled. Awesome. Let's go back to the web console, and you can see that I'm disconnected. I can't do anything here. If I click on anything, it's not going to work. If I try to reconnect, it should not function because that service is shut down. The program is shut down as well. The port is essentially closed. Good. Let's go back to our scan here. Let's do the scan again from another terminal. And you can see, indeed, 9090 was open, but now it is closed. All right. The next one is 8200. Okay. What is it? What exactly is 8200? Well, again, like I was saying, this could be used by a lot of things. It could be and I just had to answer that real quick. It could be that we're working with something web-based. A lot of web-based systems will use port 8200. It could be that we're working with a special type of program. There's a lot of options when it comes to port 8200. So I want to know what it is on that system. So I'm going to go back to my SSH into that system and take a look. Let's do a systemctl, and we'll do, what do I want to do here? Let's do a list unit files, and this is a common command that I'll run. You can see it's here, list-unit-files, /type service, and I'm grepping for enabled. I want to see what the enabled services are on this particular system. So we'll press enter for that, give that a moment. And you can see the whole list here. Okay, so this is what I typed. You can see everything that's running. If I wanted to harden this system more, and by the way, this is Ubuntu desktop. It actually has a desktop, and it is not a pure server. If it was a server, it would have a lot less services listed here, and some of them wouldn't even be here, like Bluetooth. But if you did see something like this, you might say, okay, I don't need that. I want to harden my system, so I'm going to get rid of that. Similar to how we did with the cockpit.socket. Okay, so let's scan through here. We've got cron, we had app armor, okay, grub, LVM, okay, all stuff that I most likely want. OpenVPN, that's questionable. Maybe we want to shut that down as well. We could go through the whole system this way to try to harden it. But I'm just scanning through here to see what could possibly be 8200. We have SSH enabled, and I want to keep that because I do want to be able to SSH into this system, and that's in fact what I'm doing right now. So lots and lots of stuff here. UDisks, UFW, I'm probably not going to use. I'm going to go with something more secure. I probably will go with either Firewall D or just go direct and use NF tables with the NFT user space command. But here, ding, 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 vault.service. This uses port 8200. It is enabled right now. So this is HashiCorp Vault, which is used as a secrets management program. You could use it to store passwords or any type of secrets for an entire company. So Vault, HashiCorp Vault, that is most likely what's going on here. Let's see if we can run a Vault server. We'll just run a dev server. And we can. Here it is. It's running a Vault server. And look what happens. When we do so, the default listener is port 8200, right? So that is actually running now. We have a Vault server running, and if we tried to connect to it, we could from a browser on port 8200. We're going to press Control-C to break out of this. Another way to scan this system locally is to use the netstat command or the ss command. And so, for example, we could do something like ss-ant. And when we do so, we'll see what ports it's listening on, 8200, right? Okay, so that's a Vault thing. Even though I turned the Vault server off, it still keeps that port open. So I'm going to disable that Vault service. So systemctl, -- now, disable, and this time it's just going to be Vault. Okay, triple authentication here. All right, there we go. And so let's, and I should have typed sudo, so I did not, but let's take a look here. And we'll go back to our other terminal and run that NMAP scan again from my main system here. There we go. 8200 is now closed off. All right. So chances are, if you're using 8200, it's some type of web-based system. It could be the old TrivNet, but that's not most likely the case. It could be Duplicati, which is something that allows you to duplicate data in an encrypted format, or one of many services that use port 8200. Do you have to use 8200 for your web service or for Vault? Not necessarily, but that is one option there. Okay, so that is closed. Now, port 4000, that is, I had mentioned before, that is NoMachine. Okay, here's my NoMachine program. I use this to graphically control remote systems, and the name of this system is Telemetry. It's an Ubuntu 22.04 workstation. Okay. So that was definitely a lot of fun right there with the echo. That's because the audio is turned on that system, but that's essentially what it is. So I can control any system on my network here, on my local area network, with this program. Okay, here we have a Debian Linux system, and it's actually not coming up right, but that might just need to be updated. Okay, good. There it is. All right, and so this is a laptop running Debian, and so we could do whatever we want here. Take a look. Oh, let's just let's do this. Let's do an ss-ant and take a look. Ooh, a bunch of ports. You know what? Let's do it with TUN. That just gives me the established ports right now, and we can see 4000 is open. That is NoMachine. So it's a really good program. I don't really trust it for internet connections, but I use it all the time on my local area network. And so I could scan this system too if I wanted to. Go back to my main system and do a scan on that guy. I don't know who it is. I haven't done a full sweep of the network yet, which is time consuming, but I can just find out real quick here, 10.42.48.10. So let's try scanning that guy from my main system. There we go. And it sees 22 SSH is open and 4,000 remote anything. Okay. So my NoMachine. Good. All right. So there is some stuff that we did here. We really locked down this system pretty much. To lock it down further, we would turn this off most likely, especially if you're in a more enterprise environment. You probably would not run NoMachine. But SSH is something that you might work with. And who knows, you might change the inbound port and do other SSH security. That's another story for another day. All right, let's get into a little bit more. So far, we've been scanning TCP ports, but you can also scan UDP ports. And if you want to do that by default, you can do the -S capital U option, which will require sudo privileges here. Okay. And we'll give that a moment. Okay. That may take some time. Let's go over to our virtual machine. There we go. We saw before when we did a scan of the virtual machine's gateway that 53 was open. Well, 53 is DNS, and that by default will use UDP and TCP. So we could attempt to scan individual UDP ports, because you'll note that -SU for scanning all UDP ports can be time consuming. So it could be that you want to speed that up. There's a variety of ways to do that. One way is to just scan the individual port number that you want to see. So we could do something like an NMAP-P and say 53 for DNS, and then -S uppercase U. And again, with sudo privileges here. Okay. Oh, and I didn't specify a target. Silly me. Let's do it again. There we go. So I did it correctly. First of all, sudo, because you need administrative privileges. Second of all, nmap 10.0.2.1. Then I specify the port. And because I want to see the UDP version of this port, I do a -S capital U. And it indeed says 53 UDP is open. Now, previously, if we go back here, when we showed 53 on our main scan, that was showing the TCP version, the guaranteed version of UDP. So when you do a standard scan against an IP address, that's what NMAP does. It looks for TCP-based ports. If you want to get UDP ports like this, then you have to specify that with the -SU. But again, it can be very slow with user datagram protocol with UDP. So you might want to just specify the port or the port range that you want to scan. And so we showed that before. You can also do that with a -U and colon and specify the ports. And we would actually have to do this. Oh, that's not right either. Oh, I didn't add the SU on the end. I thought I had this right. -P. -P. What am I? Oh, I have a dash in there. Don't need a dash before the U. There we go. So my apologies for that. This would be the syntax. And then you could add additional ports here just by comma separating them after the 53, and that'll specify all the UDP ports that you're possibly looking for. Very good. All right, so let's move forward. There's a whole ton more stuff you can do with this. Let's see if our UDP scan completed here, and it did not. It's not even done yet on that system, so I'm going to Control-C out of that. There are ways to speed it up. I just showed you could do a specific port number. Another way to do this would be to do a sudo nmap -suv -T4. That's the timing template. I believe it's 1 through 5. The higher the number, the faster the template. And let's do -F and --version-intensity. And we'll set that to 0, which is the lowest. And we'll test on .15. And you can see I have some of these commands were typed previously. And we'll do this with -PN to get through to those ports. Let's press enter and see how long that takes. Now, so far I've only been doing IP addresses. You can also do domain names if you wanted to. You know, you could do an NMAP directly on a domain name. You could do something like -A -T4 on example.com or prouse.tech and just see exactly what is happening on that website. But only do that with websites that are testing sites or sites that you have that you own and are allowed to work with. Okay, that one finished. This one over here on .15 is still fairly slow, but this one did finish, and so we got a whole good ton of information about prouse.tech. So feel free to do that. We've got IP addresses. We've got ports that are open. It's showing 80 and all the information about that. It should also show 443, and it does, and all the information about that. Lots of info here when it comes to using that command. That was this command right here. Okay. Oh, and this one finished. It took 1 minute. Good. So that is definitely faster because this here was running for several minutes while I was yapping and showing other screens, but this one took a lot less time, just 1 minute altogether. So it scanned 100 ports, but did not find anything on that particular system, and that's because it's not running any open UDP ports. If you were to do this on a system running DNS or something like that, you would see port 53 or other ports open. All right, awesome. So that is a ton of NMAP stuff, and that's really only scratching the surface. That's just the tip of the iceberg right there. To find out more, I have a couple suggestions for you. One, do an nmap --help, and that's going to give you the main help page. We'll scroll up on this. It's a pretty big help page, but it gives you all the specifications, host discovery. For example, we did an SN for a ping scan to check all the systems, scan techniques, port specification, which we showed, and there's a whole ton more stuff here. So more than you can shake a stick at, right? But you can also go to the manual page. So if you do a man nmap and press enter, you will see a ton of info here. This is actually one of the most well-written manual pages I've seen in a long time. One of the cool things they do is they basically copy the options. It's the same in the help file as in the man page, but then you get lots more descriptions about things that you're doing. Like if you wanted to specify targets, if you want to try to find rogue wireless access points or rogue FTP servers or something that's possibly malicious. So the man page is very, very good. In addition, NMAP documentation, and that's at nmap.org/docs, and I'll put that link in there. So that's another thing you can go to. All right, and I do see there are a couple questions, so I'm going to answer those as we go. Actually, I think I answered the first question in the chat. And the second one I will be answering in a little bit. Okay, good. So awesome. That's and by the way, there's a book as well. The author of NMAP has a book also. You may be interested in that, or just working within the documentation. Documentation is everything. You got to have good documentation in order to have your program accepted as a decent program by the masses and adopted into the ecosystem. So definitely good documentation here. It's one of the reasons I've used this program for like 20 years more. All right, so that is that. So now we can move into some additional stuff here. And yeah, that's right. The way I'm doing this channel is you can see me, you can see my my shared screen, you can chat in the built-in chat in this channel, but you cannot speak, right, or share your screen. Okay. All right. So let's get into some other stuff. We said we were going to cover a couple other commands here. And so the first one is the IP neighbor commands. Let me clear out of here. Go full screen on this. Okay. So IP neighbor, first of all, the IP command has lots and lots of options. I showed IPA to take a look at what we have here. A, or address, is the object. And then you can have options in between there. Well, there's lots of different objects. There's address, there's link, there's tunnel, there's route, and I use all of these often. And then we also have NA, short for neighbor. And you could just abbreviate that by doing an IPN. All right. So let's go back to our virtual machine, and we'll do exactly that. Let's run an IPN, which is short for IP neighbor. And you're going to see two possibilities. Okay. The first is 10.0.2.1. Okay, so we're scanning the network once again. That's my gateway. It is reachable, and a reason for that is because I have been making connectivity to that gateway. We also see 10.0.2.51. That's the Debian server that I also have running as a virtual machine. That says stale. That means that we haven't made a connection in the recent past, right? But we can make it show as reachable. We could just ping that system or connect to it in any way you want, and then run that IPN command again. And actually, it's showing stale for both now. That's weird. They should both show as reachable. Oh, I'm sorry. I just did a 10.0.2.1.51. Okay. And now run the IPN. Now we have a delay here. That one you don't see as often, but generally, there we go. Give it a moment to finish that, and now it shows both as reachable. Okay. One other thing you'll note here is it shows the link address, the data link layer address, layer 2 stuff. That's the MAC address that we're showing here. So this is the MAC address of my gateway. This is the MAC address of the server. If I jump over to the server, we can prove that. What's the last two octets? E2:DA. We'll go to the Debian server, run an IPL command, and we will see what we see. Here we go, E2:DA. So that is the MAC address for that server, as expected. But these are virtual MAC addresses because these are virtual machines. So if we were to look somewhere else on, say, let's go to this system here and actually run an IPN, we're going to see a lot of stale connections, but we'll see the actual MAC addresses for those. Okay, on my test network here. Good. This one, that's the server. I actually have connectivity to that virtual machine as well. So that one is actually a virtual MAC, but the bulk of the rest of them are actual MAC addresses on actual network interfaces. cool. Back to our virtual machine clients. There's a lot you can do with the IP neighbor commands, but this is kind of like the new ARP command, sort of. If you want to see a system's IP address and its corresponding MAC address, so you have the network layer IP address and the corresponding MAC address on the data link layer underneath it, this is the command to use. ARP, or Address Resolution Protocol, is being shown here. The ARP command is considered deprecated, but this kind of takes, that's kind of the new version, IPN. But you could also use ARP, and we'll show that in a little bit. We could also modify this. We could say, okay, what if we just want specific information here? We could do an IPN pipe, use the awk command, and do something like this. We'll print the first line of, first item of information here. When we do so, we just get the IP addresses, all right? Or we could just do the MAC addresses. This is the first item, second item, third item, fourth item, fifth item. So if we were to do that, we'll just get the MAC addresses. And we can export that information as we see fit. Or we could combine them if we just want to have the IPs and MACs. Okay? So IP neighbor, another command that you can use to work on your system. All right? All right, so another tool that some people use, and this is a graphic-based tool, is Angry IP. This is a fun tool. I'm going to open up a browser here. And yes, we're going to show ARP, but just briefly. So let's do a search for Angry IP. Here we go, angryip.org. Download for Windows and Mac and so on. So you can grab this here. I'm working in Linux, so I want to grab the Debian package for Debian. So we'll just download that. There we go. And so we can go to our terminal, change over to the downloads directory, take a look inside, having trouble typing. And there's the IP scan program. So we can run that now. We'll do a sudo. Or install it now, I should say, with a dpackage-i. Good. Errors, IP scan. Okay, dependency problems. Well, that's not nice. I'm wondering if we can just install this with apt. We can. Okay. So we're going to do an apt fix broken install because we just messed up the install before. So normally the install would go pretty easily. So you can install it for your OS as you see fit. But let me try to fix this here. Okay, good. Okay, and now we'll do an apt auto remove, just in case there's any junk that needs to get removed. Okay. There we go. So now IP scan should be fixed. Let's run it. There we go. And Angry IP Scanner is running. And by default, it sees what network you're on. For me, it's 10.0.2. And it says, okay, we're going to scan between .0 and .255. Let's start it. Okay, it finds the gateway on 10.0.2.1. And it sees .51. That's the server. Scan complete. Oh, and it told us 3 are alive. Okay. And we see the client, which is this system. So another cool program, Angry IP Scanner. Oh, if you want the link for that, you can just search it in Google or your favorite search engine. Okay. We'll link that in there. All right, good. And so there you go, another tool that you can use to do scanning of your network. Real basic tool. Another command, I'm just going to close that out, that actually doesn't fork from the terminal. Another command is the FPing command. You might like the FPing command. it may not exist on your system. And in fact, if you're running Debian or Ubuntu, it will not by default. So we need to grab that. So we'll do a sudo apt install FPing. Grab that program now. And then we should be able to run it. So we can check one or more hosts with this. For example, we could do an FPing of a specific system like 10.0.2.1, and it'll just say whether it's alive or not. Okay, so a nice little program. You can specify multiple IPs just by doing comma separation. Okay, both of those are alive. You can check an entire network. FPing. So FPing, that would be -G, I believe. So we would do an entire network like this, 10.0.2.0/24. And it'll go through the IPs for that network. And it's going to give these error messages for the rest. But it saw the 3 that were alive. Okay. We could fix that so it doesn't give us a bunch of garbage. We could do something like -R1 and then grep for alive in double quotes. Oh, that didn't actually work. Let's do this. That should place the garbage in the bit bucket. There we go. 2 greater than 1. That'll drop all of the error messages into the bit bucket and just show us what we want. Right? Good. All right. So that's another one. Lots of tools here that we can work with. Let's go down to here. You know what? Let's do this. Let's run a Wireshark packet capture. Now you have to have Wireshark installed by default. I'm going to do a packet capture on this. And this is the interface I want. So we're going to go to capture and start. Very good. We'll let this run for a little bit. And let's do a little connectivity here. Okay. Run another IPN. Now let's run an ARP command. Oh, ARP doesn't work. All right. Well, let's actually take a look at our Wireshark. Let's stop this. And let's see if ARP, if there is any ARP in here. And there is. I'm filtering for ARP. And we do actually have some ARP information. My system is talking to this system. This is a super micro system, and that is the Ubuntu workstation we were showing before. It's talking to my system directly. And basically this system, the super micro system, is asking, who is 10.42.0.243? Tell me. I don't necessarily want that. I don't want that Ubuntu system doing that. So I'm either going to go over there with a hammer, or I'm going to make sure that ARP is turned off. And it is actually telling it who it is. And we're seeing this happening with Wireshark. This is a very basic example of using Wireshark. But address resolution protocol does happen sometimes. And what it does is it resolves between the IP address and the MAC address of the system. So these are the IPs here. And here, these are the last 3 octets of the MAC. Right? We don't need the first 3 octets because it's telling us the name. The first 3 octets are the organizational unit identifier. So Supermicro has its own OUI. Intel has its own OUI. That's the first 3 octets of it. What we're more interested in is the last 3 octets. But I may or may not want ARP running, so I might go to my Ubuntu server and junk it, get rid of it. But you can also run ARP locally on your system. So ARP is the address resolution protocol. This is an older tool, but I still use it in some cases. Now, if you try to run it by default, it's going to say command not found. You may have to do it with the sudo command. If it's not there at all, if you can't locate it on your system, then it could be that you need to install it. Today, most of the systems that run Linux do not have ARP. They consider it a deprecated command, not necessarily a deprecated protocol, but a deprecated command. But you can still get it back. You could do a sudo apt install net-tools. That will give you a whole boatload of tools. For example, route, netstat, ARP, and several others. And at that point, we should be able to run the ARP command with sudo. And now we can. Good. But requires sudo, because ARP is the program in Linux actually has some inconsistencies. They deprecated it because it's older, but also because it has some security vulnerabilities. And so FPing, IP neighbor is a better option for this. But you could still run ARP if you install that program. And you can see here that we have this server IP and we see the MAC address. Okay. The normal way that I'll run this was with a -E or with a -A. When we do a -A, we actually get the resolved IPs here. Here we see the gateway. Here we see the IP for that. So sudo ARP-A is what I'd run most of the time. All right, awesome. If you don't want to resolve names, you could use -N. Info is stored in proc/net in/net, and then if you look in there, you'll see ARP. If we do a vim on ARP, you'll see any IP addresses that we've connected to in the past and their corresponding hardware information. Now, back in the day, especially on like Windows systems and domain controllers, things of that nature, I would add a static entry for the MAC address into my workstation so that it would communicate directly to that server without broadcasting on the IP layer 3 network layer. And just connect directly. Let me rephrase that. I would use this so it would communicate directly to the IP address without trying to hit all other MAC addresses on the underlying data link layer. So I would do that with something like ARP-S, the IP address of whatever I wanted to connect to, and then its corresponding MAC address. So, you know, whatever that is. And actually you would use colons, right? Or dashes. And so that would add a static entry in there. Let's just make a fake one. Got to do it with sudo. There we go. And now let's take a look at the file again, and you'll see there's my fake one that I just added right there. But that would allow the IP address of my system to communicate directly with the IP address of that other system without doing all broadcasting on Ethernet to all the MAC addresses, right? That is still a possibility, but not something I do very often today. All right. So that is another item there. If we go to our main system, we could do an ARP. And let's say I wanted to connect by name. I could do it with a -A on, say, telemetry, if I could see that system. Do I have this here? I do. Okay. So that's on my main system. So I actually do have ARP. But I kind of recommend that if you don't need ARP and you don't need netstat and you don't need route and all the other commands that come with this, I would say do a sudo purge on NetTools. Anything that you don't, sudo apt purge on NetTools. Anything that you don't need, you should most likely get rid of. So if you test it and it's fun and you want to use it, that's great. But if you don't think you're going to use it much, dump it. uninstall it either with the sudo apt remove, or better yet, a sudo apt purge, which will get rid of any configuration files associated with it as well. Good. But on my main system here, I did this ARP-A telemetry, and it does name resolution from the name telemetry, which is my Ubuntu workstation that we showed before at 10.42.0.15, and shows that corresponding MAC address on Ethernet and the network interface device that's using that. All right, so that's another way to use ARP. Awesome. Okay, so a couple other things real quick. Another way to scan for systems is to use for loops. Let me just paste in an example of a for loop here. Oh, this isn't going to work. I have to go into a bash prompt. Okay, here's an example of a for loop. This actually isn't going to work here because I would have to change the IP networks. So let me do one more thing. You know what, I'll go through NoMachine so I can paste this in really easily. Here's my Debian client. There we go. So I'm connected in here with the Debian client. All right, live stream still running, good. And let's paste this actual command directly in here. There we go. Okay, so this is going to do a for loop. It's going to look for IP addresses in a sequence 1 through 254. It's going to do a ping with a count of 1 ICMP echo. Oh, let me get my, oops. Get myself out of the picture there. But it's going to do a ping with 1 ICMP echo against this IP network, and then we're using a variable. And the variable is this. It's going to be a sequence between 1 and 254. It's going to keep iterating in that for loop, 1 through 254, one at a time, sending the results to dev null, but it's going to echo whether the IP address is up on my screen. Okay, so we'll run that. And here we go, 10.0.2.1 is up, but this is kind of a slow program, and for loops can be slow. So this could take a while. I don't know how long this is going to take. It could take 10 minutes to scan just 254 IPs. So you could modify this. You could change this to just 1 to 10 or something like that just to test it. There's all kinds of options for doing for loops on your system, and that'll give you the information you're looking for. However, I tend to go more with while loops instead of for. And I'll give you an example here. And let's connect over here to another browser window. This is one of my GitHub repos. And you'll see here, make this a little bigger, the superping script. And if we go in there, you'll see this is a script that I've written that will look for whatever systems you want. You could script a while loop to scan entire ranges if you want, but in this case, instead of a range, which we could have easily done the same way we did with the for loop, $IP or something like that, and give a sequence of numbers. In this case, what I'm doing is saying $system name, and I'm specifying system names or IP addresses in a file called computers.txt. And so that's listed here. Very good. And so that's something you might be interested in, the superping script. But as I say, this makes use of a while loop. So what I'm doing here is I'm running the cat commands to read computers.txt and piping the information for those individually with a while loop. And it's reading that information from computers.txt. And it's looking for anything known as a system name. And we're just using that as a variable. Then we have a do statement. a do process where we're doing the ping, checking each system name with a $, it's a variable, one at a time, dumping that results to null. And if the EQ code is 0, which means it worked and the ping got a response, then it'll say that this particular host is alive, and write that to this file, replies.txt. And then if not, the else statement, it's dead, and it'll write that to noreplies.txt. And it'll put those files directly in the superping directory. And then just some printf statements stating that everything is finished. So I have that version and also a terminal version to just run the responses directly in the terminal standard out. Okay, so check that out. I'll paste that into the group chat as well. Awesome. Okay, cool. So that's another example. So that's a while example. But again, like I say, you could use for loops, while loops, whatever you want. Let's go back to the virtual machine. It's only gotten as far as 52. It's a cool script because it's not showing anything that isn't alive, but it's only gotten this far. I don't know how much farther it's gotten, but it's still definitely taking a long time. We could have put the time command before the for command to show how long it took at the end. Or we could use progress as well in Linux. All right, so that was a lot. We've been doing this for an hour 15. I think that's enough. The big tool that we were using today, though, was NMAP. And it was definitely a super powerful tool. And we showed how we can use NMAP to scan and do network discovery. And we showed how we can scan individual hosts and their ports that are open to see if there's any services we want to shut down and harden that system. You can find rogue systems, rogue wireless access points, FTP servers, gaming servers, all kinds of good stuff. And we specifically showed this system where we shut down cockpit.socket, that's your web console, and also Vault, which was running on port 8200. And now we have a cleaner system. The only thing I have to do now is get rid of NoMachine, but actually I don't want to do that. I want to be able to connect to that system remotely. Awesome. So that's about it. Let's see if there's any last questions that I didn't cover here in the group chat. Okay, and so that is good. All right, so yes, the ARP command required you to have ARP. So you would have to install it. So you'd have to do a sudo apt install net-tools, replace your package manager with what you have here, either an apt or DNF or whatever it is. And then once you have that, you'd have to use the sudo command to actually run it and do it with a -A or a -E, and you can find various MAC addresses that correspond to the IP. Okay. Another question, how often do you use NMAP and Wireshark? I use the two of them a lot and in unison a lot. So definitely two powerful programs, definitely good to have under your belt. Okay, let's see if there's any other questions. I think that's pretty much it. So we're going to close this out, and that was awesome, and I appreciate everybody coming on board today. It's good to have you all today. That was cool, and you might be able to see me in the webcam as well. So great work, everyone, working on your systems. If you have any additional questions, feel free to post those in the Discord channel in the questions random chat. But that is about it for me, and we're going to close this out. This was really off the cuff. This was just my first Discord live training, so I appreciate everybody getting on board with this, and I hope you learned something. And we're going to post this we're going to post this on YouTube, and you can view it there if you want. And so if anybody missed it, you can view it there. And we'll put a link for that in the Discord channel. All right, that's about it. Keep practicing with your systems, especially NMAP. Awesome, awesome program. Something you definitely going to want to work with, and especially check out the help file for that. It's massive. The manual page is massive, and also check out the nmap.org for documentation as well. Great job, everyone. That's it for me. Signing off, and take care.